Okay, we have everyone. We should be able to get started now. Okay, so last time we talked about the basic program structure and also data types. Today we are going to talk about the operators and expressions and start to write some simple programs. Okay, so today's okay. So today's goal is this operator and expression. So we talk about casting and range of variables, compound assignment operators, and program units, static program, object-oriented programs, operators, increment, decrements, integer division, modular arithmetics, operator precedence. Okay, these are different things that we'll talk about today. Okay, so basically different operators and how to write a program, simple mathematical program. Okay. So that's the goal for this. Okay, but before we get started for this, I would like to talk about something else. Okay, I would like to talk about something else. So first is, I would like to talk about, here every year I release a note for the road to UCCS to how to study for computer science in University of California. Okay, every year I release this, but anyway, what I want to emphasize is in high school, what should you need to do? Okay, in high school, when you do, some of you, I already show you this, but you may already taken the Python course, okay, Python 1, and then maybe I also teach you HTML, JavaScript in APCSP. Okay, and now we are on APCSA, so APCSA will cover you Java 1, 2, and maybe a little bit of Java 3, okay. And then later you still need to have the C+++1. So we try to make you 4 language ready before college, okay, before going into college. And once you are ready for Java and the C++, we will allow you to get started to the competitive programming for problem solving. So user code and the data structure and the discrete math, these are needed over here. And this portion is competitive programming and it's problem solving based. So our coding bed, okay. So our coding bed actually is to help you to learn how to do problem solving. Our coding bed is level 0. I mean, that's just preparation work. Okay. After that, you still have many things that you need to do before you can do the competitive program in high school. And later in college, you move on to LeetCode and also Codeforce for internship preparation. Okay. So this whole thing is competitive programming. So you take APCSA and C++, you are going to this route. Okay. And then besides that, for computer science, it's not enough, okay? It's not enough. It's way not enough. If you just do problem solving, it's not enough. You still need to know about how to design a website. And the website has the back end and front end. So you need to know about database for back end and front end with the user interface. So from here, you go into here and this actually, you go into this website design, okay, including the back end and front end. And then from the Python, you actually go into mathematical study and also data science, machine learning, and neural network. Okay, and these two combined, you can participate in the hackathon competition. And then they'll go into the research and science board, okay, using computer science. So these are the overall things that you need to do in high school. So there are tons of things you need to do, okay? Tons of things you need to do. So if you finish our homework is just the minimum requirement. if you finish our homework, there are still a lot of things you can do. At least you can work on a W3 resource for more problems, okay? Or you can actually also work on some of the projects, side projects, okay? Also, you need to work on some side projects. So to study computer science, okay, to study computer science, our way of studying is like this. You do take a lecture, okay, so you take a lecture. So right now you're taking the lecture. After you taking the lecture, you study the material, and then you work on those quizzes. Okay, you work on the quizzes. After finish the quizzes, you try to solve problems. So this part is your exercise and your coding back. Okay, these are problem solving part. And after you can solve some problem, you need to work on side projects. Side project means that you work on a project that is really a piece of software, really do meaningful things. And then you go back to learn more things and make several cycles over here, okay? And the project size should keep growing until you can really write a big game or a big system by yourself. So this portion, you have to spend some time as well, not just, okay, we give you the practice, mostly quizzes, exercise, and some small project, but you do need to explore more of it by the side project, this including individual research project, and maybe also participate hackathon, okay? Because the project we assign you cannot be a project that you need to work for a week or even a month, cannot be that size. So you have to find some of the project of that size. Those kind of individual project, even when you apply for college, you can write it on your resume, okay? So that is also very important. As for you are ninth grade, eighth grade, okay, or you are 10th grade or 12th grade, it doesn't matter, okay? No matter which grade you are. We talk about capability, we don't talk about your grade, okay? You want to study it, you need to move up the ladder step by step, okay? You need to move up the ladder step by step. So it takes time to accumulate all these experiences. And when you go to college and major in computer science, you kind of need this, okay? Kind of need this. And for this machine learning part, you also need to learn a lot of math and physics, okay? And then you learn C++, you do problem solving. And here there's another branch for science ball, or you actually also can work on robotics. So robotics is somewhere in here. It's one kind of the competition, but it requires the problem solving and also hardware driving, okay? And those are things that you want to work on in high school. So basically you are right here, okay, APCSA, and then you may already taken Python and Introduction to Computer Science. You may already finish this too, you are here. And then after that, you will go here. So you also need to build up your MC 10, 12, AMI, okay, American Invitational Mathematical Competition, okay? And also you, in high school, you will join the club, okay, programming club, robotic club, data science club, okay, data club, and online courses for math and programming, okay? And then also from here, you go for hackathon. Okay, this you require the website design capability, go to hackathon. And then after you compete in hackathon, you can also host hackathon. Okay. And here you also may participate in the robotic competition. You may also join the entrepreneur, okay, programs such as start companies preparation, okay, research program, research, and then AI competition, Crackle, okay, Crackle, and then schools honor society, okay. So this map, I did not come up with it just by my imagination, okay. Actually, this whole thing, my own son and student have do experiment on this before, okay? Everyone, several of them go into these different passes, okay? So still a lot of work to do. Don't waste your time. Don't play too much game, okay? You play game is okay, but don't take it as your primary job, okay? That's actually is wrong. And then another thing that I would like to talk about is in your high school, okay? In your high school, okay? In your high school, you may have UC A to G, okay? A to G, you have A category, that's a social studies. So you do geography, AP Euro, AP US history, AP World, okay? And then AP microeconomy, and then English, okay, you have honor 10, honor 9, honor 10, AP Land, okay, honor 11 or AP 10, AP Land or AP literature. So this part, humanity, that's fine, okay? And then you have elective world language, you need to have some AP language that's actually needed. Okay, this part is easy. But the more difficult part is the D part, okay? UC A to D, D is science, and C is mathematics, and also G, C, D, G, computer science. Computer science is very mixed. APCSA is considered to be a math course. APCSP is considered to be a science course. So it's actually between A, C, D, and G, three groups, okay? But this one actually, as you can see, there are tons of different courses right here. Your high school may only offer 3-year science or even 4-year math, okay? But that's not enough to prepare you to be a top programmer. So there are some other courses you need to prepare yourself, okay? Calculus, degree math, linear algebra, multivariable calculus, differential equation, okay? AP statistics, AP calculus BC. So even AP calculus BC is just the beginning of the college courses. So how far can you go? Up to yourself, okay, up to yourself. For science, you have honor biology, honor chemistry, AP Physics 1, AP Physics 2, AP Physics C, E and M, AP Physics C, M, and then you also can go for USA PHO, okay, Physical Olympia, okay, and then whatever, there's tons of courses you can do. And also programming course, you only finish CSA and CSP, but there are more JavaScript courses, data science courses, C++ courses, data structure courses, embedded system courses you can do. And then all of these help you to organize the research paper and the robotic competition and the summer camp. So eventually you want to stand out, it depends on this part, not the coursework. The coursework, everybody has it. But you need to prepare yourself to be able to reach here. If you don't take enough course, you cannot compete. Okay, that's why some of you start early in 8th grade, you already take APCSA. But that's not really enough. You have to keep progressing aggressively and then build up your own track record. So as you can see right here, I have maybe 10 more bubbles. These are different schools that my son used, okay? The Washington High School, the International Connection Academy, Arizona State University, Full Hill College, International Virtual Learning Academy, okay? Philadelphia Homeschooler, okay? These are different high school that he used before. And the whole thing just to build up a record to help him to do research and competition, hackathon, robotics, USA PHO, Amy, okay, all kind of competition. And those will lead to his future study for electrical engineering and computer science plus business in Berkeley. Okay, and now he moved on to Stanford. So that actually is a long route and you need to prepare yourself, okay? That's what I want to say. Don't waste your time, okay? Don't waste your time on useless stuff. There are tons of things you can do, and while you are doing some little things. Some other people are already running faster than you, okay? But you need to take it step by step, okay? We don't jump step as well. Okay, anyway, we get started from here, and then this chapter we are going to talk about elementary programming. Last time we talked about some basic input, okay? And then we talk about some data types. And today we are going to talk about program structures, okay? Operators and precedents. So program units, okay, program units. Program units we have starting from smaller one, that's one token, okay, one token. So token is a computer term. In English, it's called a word. A word is a token. So if you actually look at the AI, okay, AI, if you do natural language processing, you always hear that, oh, they are using 1 trillion tokens. Okay, 1 trillion tokens. Let's actually show you. The processing power is a large language model with 1 trillion tokens. LLM with 1 trillion tokens. Platform, okay. So there are some papers that people deal with 1 trillion tokens. So this word token is, okay, let's actually look at it. You have I love you, right? You translate it to Japanese, let's see, actually it's 私はあなた I'm sorry, を好きです。Some of the later I may not write it well, okay, because I use a mouse to write. Anyway, so I is a verb. I'm sorry, I is a subject, love is a verb, and you is an object. So this is a nouns, pronouns, and pronouns. Okay, pronouns and pronouns. And you translate to watashi. Watashi actually is I in Japanese, but this one is a pronouns. Anata is you, so it's actually pronouns. And then love is skides, like, okay, like skides. So this one is a verb. So you are translating from nouns, verb, nouns to nouns, nouns, verb. So Korean, the same thing. Korean, I think, also use this nouns, nouns, verb structure. So in terms of grammar, you are translating from one grammar to the other grammar. You kind of have a translator. From one language, you put tokens in. You get tokens out. And these different tokens, input and output, we call it stream. This is input stream. This is the output stream. And then the number of tokens that you can process, we also call it parameter. That's your computing power, 1 trillion token translation power. That's the large language model, right? And you have the input stream, you have the output stream. So basically, this is actually NLP, natural language processing platform. When we talk about tokens, what is token? Token is a word, okay? And token also means how many parameters you have, okay? And then in our computer, let me emphasize one more time, you have a keyboard. You do input. So there's a keyboard, we call it system.in. This is an input stream, input stream. Okay, and then you got an input buffer right here. So this input buffer, you actually do scanner input equals new scanner and then system.in. So basically, you put a system.in right here. You are hooking up keyboard with the buffer. The buffer is called input. So in SoloLearn, they use SC scanner. SC is scanner. So this hook up your input stream. Okay, hook up your stream. So this one hook up your input stream, and then when they release data, it's token by token. So it's actually there is a function you can get one token from another. So basically, this keyboard input is A, B, C, 1, 2, 3, whatever, keep going. These are called input stream. And then you read one word, that's one token. Two word, that's two token. So you say next, SC the next, or input the next. The next means next token. Give me a word, please. That's the next token. If you say next integer, then it will give you next integer token. You may have a next double, that's next double token. You may have a next line, that's using a line as a token. Any questions so far?
No.
No? Harrison, are you okay?
Yeah.
So that's the basic minimum unit is called token. That's a word, single word is called token. The next one is expression. So you got A times 3. A is a token, 3 is a token, star is a token. A times 3 is an expression. So this expression, actually, we can call it a phrase in English. So token is a word, or expression is a phrase, or sometimes we call it part of speech, part of sentence. Okay, so that's expression. A times, but it's not a full sentence. It actually is a grammatical unit. Okay, so expression usually will give you some value. They'll return you some value. Okay, return you some value. Now, next one is a statement. Statement finish with semicolon. It takes one action, one operation, we call it statement. And then in English, it's one sentence. Okay, in English, it's one sentence. So you have one sentence, each one of them finish with semicolon. In English, the sentence finish with period or question mark or exclamation mark, right? That's a sentence. And then next one is a method. Method also called function. Okay, so you have next integer. Next integer itself is a function. So you have the ABS function, absolute value. That's also a function. A function is equivalent to a paragraph in English. Okay. So it's actually similar to a paragraph. So your one program may have multiple paragraph. One program may have multiple method. Method we also call it function. Okay. And then this one is a class. Class is that every time you start with a class A and so on, so many things over there. So a class is an essay, is an article, it's called a class. Okay, just like English is an article or an essay, it's a whole thing that you have a title. Okay, so introduction to computer science, that's a title of the article. That's an essay. Then next one is a package. Package is a whole book. There are multiple chapters, multiple essays. It's a package. So you have import Java util.scanner. So util is the utility library. That's a whole library of the code. Okay. Any questions so far? So these are different program units you have. Okay. Now let's actually go back to here. Okay. So here, every time we get started with a class, you can choose abstract class, interface, unit test, enum, Java FX class. These are different class type. But so far, just use the class. We will teach you some of them later, but at this moment, just use the class. Okay. But here, let's actually get started. Let's assume that we do something like, yeah, let's do circle. Okay. Let me try to use the circle one more time. Okay, so circle. So when you create circle, let's take out these comments. These are useless. You basically get started with this. Okay, so this is public. With or without it is okay. Public just tell people this is public, everyone can use. Without it, it's also okay. And then let's actually put it back. Okay, so you have a public class circle. And then right here, you finish this one, you do save. And you go back to your hard disk. So here, chapter 3, you do have a circle that Java created. So circle that Java got created. So your file name is circle.java. Your class name is class circle. So your file name and the class name need to be the same. Okay, need to be the same. So here, if I change it to circle1 and I do compile, okay? So here, my project view already changed to circle1. And then I go to my directory. Here, it has a circle. It changed the name of the class file name to circle1 as well. So file name need to be consistent with your class name. Any questions so far?
No.
No.
Okay. So your homework, okay, so your homework, some of you, maybe you write the homework, say exercise 1-1, okay, that's actually fine, okay, I'm fine. But if you use the name, say ticket, it's also okay, it's also okay. But as long as I know which program it is, or you use a temperature, that's fine, okay? You don't need to every time change it to ES1 1.1 or ES11 as the name of the file name. Okay, it's actually depending on the project. Okay, so that's the file name, and then you get these. Okay, you got this, and then your main programs actually you get started with publish stated volume pen. Okay, so each one of these is a token, a token, a token, a token, a token. Okay, different tokens. So right here, if I put another one, let's say public class circle2. Is that okay? No, that's not okay. That's not allowed to have a circle2.
Oh, I think it's because it's public.
Yeah, you need to delete it. Okay. Delete it, you make it not public, so it belongs to this module. So they don't allow two public class at the same time, but we do not suggest this as well. We do not suggest this as well. Let's actually put it back to public. But can you do this? Can you actually cut this one and then not putting it over there? Let's put it over here as a subclass of the circle. Is that okay? That actually is okay. You are allowed to have a class inside a class. But can you do function inside a function? No, function inside a function is not okay. Make sense?
Yeah.
Okay. So here you do put this over here. That's actually is fine. Okay. We'll talk about class more. Okay. We'll talk about class more. But at this moment, that's actually up to here. Okay. Up to here. This one circle one just up to here. I'm not really writing a circle. Okay. Circle, we finished it already. I just want to let you know that what's the relationship between the class name and also the file name. Okay. And you can put a subclass inside a class. Now, then what is really a class then? Next one, what is really a class? So a class is a essay, a article, a program unit, right? But it's also a data type. So we can create a data type called point. Okay, so class is also a data type. You can create something called point. And then let's use a integer x, integer y, and then point, and then integer xs, integer yy, and then x equals xs, y equals yy. Okay, and then we do public, okay, string to string, return, okay. Okay, I write a class like this. There's no main function. So this one is a pure data class. Pure data class. Okay, at this moment, we don't teach you the whole class design. I just let you know that class is a program unit, is also a data unit. Okay. As for the data unit feature, we'll talk about it in chapter maybe 11 or 12. Okay. So much later. At this moment, you just know that class can be a program, can also be a data. So what's this for? Let's actually have another program called test point. So test point is a program. So test point has a public static void main. Okay, it's a very, very, very extremely simple program. So right here, we use a point A equals new point. So the point is a data class. Is what kind of data class? It actually is a data with x and y coordinate. You use that as a data type. So point is a class, but point is also a data type. So little data A is a point with the coordinate of 3 and 4. And then I print the data. That's it. So I print it out. So this test point, we can call it a driver program, a tester program, a runner program. These are all okay, okay? Any one of these are okay. Because this test point is testing the data class, testing it, is running it, is driving it. So it has a main program. While the point class is a pure data class, no driver, no one running it, no one running it. It just tell people I'm a point with X and Y, and you can use this constructor to build a point using the new function to build it. And then you use a driver to drive it. So it's kind of like you have a point class right here, and your test point is outside to testing it. Any questions so far?
No.
So here, I just let you know a class can be a data class, can be a program class. Okay? And from now on to chapter maybe 12 or before, we primarily on the driver class. Data class will be later, okay? Okay, so these are classes, okay? These are classes. So classes are basic program unit, and various class also is a data type. So when you see scanner is by itself is another class, okay? It's another class. Now, this test point, let's try another, okay? Let's try another. So let's try test point number 2. Okay, now let me actually move this a little bit to here. So as you can see, this is the advantage of BlueJ. You can show you who use who. Let me erase this part. So I'm going to test this data point in a different, so public static for email. Okay, now I have the scanner. Let me use the input equals new scanner. Systems are in. I say system is the keyboard. Okay, but you want to use scanner, so here you need to use import java.util. You can use star for everything or scanner for the scanner class only. So java.util is a package. A package is a library of several classes. Okay, but you use other people's code, so we actually need to import it. So now you actually hook up your keyboard with your input stream. Okay, you hook up this. Now let's do this. Okay, so here you put a prompt. Because if you don't put a prompt, how can I know what you want to input? Okay, let me cancel it. Get out. So right here, let's actually run it. You don't put a prompt, how can I know that what you want to input? I have no way to know what you want to input, right? How can I know you need to enter an integer? Maybe it's a string. How can I know? So some of you in your homework actually do not print for me. I will make you to redo it because what? How can I know what I'm testing? How can the user know you want me to enter a number, right? So you have to tell people that you want to have a number. So then we enter, that's actually fine, okay? Now this is good. So let's actually repeat, okay? So this one, we do this. So here, let me change it to Y, okay? I'm reading a pair of coordinate. So I read in X and Y, and then I create a new point. A equals new point, put in your X and Y in there. And then system got out the point line, your A. Now, because I use a point, so you see there's an arrow that test2 is testing the point. So this is a data class, but two testers are testing it. That's fine, okay? And these two testers are independent. Test2 has no relationship with test1, okay? And you have 3 and 4. Any questions so far?
No.
No.
No? So this one is to create a keyboard as input and read it in and then print out. So Harrison, what is the input?
Input, like you get like a keyboard input.
What do I call it?
What do you mean?
I name it with terminology. What is the name of this input?
The string?
Yeah,
Name?
use string. Okay, good. Must pay attention, okay? I'm just testing you. Okay, that's the input string. Now, that's the whatever related to the next one I'm going to talk about. Next one, I'm going to create a new document file. So this one, let's call it actually point S. Okay. So this point S, let's put in one moment, okay? I'm bringing up the editor to edit it. My computer somehow start some program slowly. Sorry. Let me click one more time. Okay, it's coming up. It actually bring up this one too. So right here, let me put in 10 and 20. So this file is a point s.txt. TXT is the text file, right? It's actually text file. So two numbers, actually two tokens, okay, two integer tokens. So two integer token was saved over here. Let me save it. Okay, that's why I also install Visual Studio Code for some student, Notepad++ for some students. Sometimes we need it. Okay, so let's go back to here. So let's actually create a test point number 3. So you see one data class, you can have multiple of the testers. Okay, let's move it a little bit. Okay, let's actually copy this whole thing over. Okay, let's copy this whole thing over. Let me put it over here. Okay. And let me delete the top part first. So let me change this test point 2 to 3. Okay, this line that's deleted, so we don't have trouble. Okay, anyway, this one I don't need it. Test point number 3. So here you have a scanner in. Now I want to put a import java.io.start. And right here, I don't want to use new keyboard. I use new file points.txt. Okay. And then this one actually is a new file. So here you need to do throws exception because sometimes you may not find the file. So this one is necessary. Okay, we'll talk about it much later. But you put this way here, so your input string not coming from keyboard now. It's coming from a file now. So there's a file called point.txt put into the keyboard input string now. Okay, in order to make a difference, here I put the F. So it's a file input. Okay, I put the F over there because I want to differentiate the keyboard input and file input. And then that's fine. The rest of them is the same. So these two enter no longer useful, but it do print out 1020. Okay. So let's delete this two statement. It's no longer human, so you don't need to prompt it anymore. So it directly read in 1020 from your text file right here. And then output. So here, let's change it to 44 and 20. Let's run it one more time. Is that okay?
Yeah.
So this one tell you what? File input. So tester number 1 is creating the point. Tester number 2 is creating the point from the keyboard. Tester number 3 is creating a point from a file input. If you have a for loop, then I can read in 20 point, 100 point, 2000 points. So sometimes you will need the file input, okay? Any questions so far?
No.
That's why I told you this part is very important, okay? You must remember the system that is the keyboard input. Okay, you must remember that. That's a keyboard input. So you can use a keyboard to input to a buffer, and you can read it into your program, right? And you can change it to hard disk. And hard disk to put into a F input. Okay. Now you do read in some data from your file to your program, and your program later will print now. Usually you type to your monitor, so it's the system.out. That's your monitor. If I don't want to use the system.out, I want to print to a file, how can I do it? So let's do test point number 4. So test point number 4, I'm going to do import java.util start. Import java.io start. Okay. This util is for scanner. This io is for file. Okay. Delete everything. Then you do publish static void name string. Then right bracket args throws exception. Okay, because you handle file, you need this throw exception. Okay, anyway, this is a main program that you created. Now you do scanner input equals new scanner system that is, so this one read in from keyboard. Okay. So because you want to read in from keyboard, so let's do system that out print. Okay, print will not change that. Okay, will not do that. So usually is used to prompt the data. Okay, so you do input x in x equals input and x integer system that out print the y and then integer y equals input x integer. No system. Okay, no, not yet. A new system A. So up to here is the same as your test point number 2. Okay, up to here, the same. Let's try it first. Okay, working. Now I want to print it to my file. How can I print it to a file instead of printing it to the monitor? So basically, I use a keyboard to read into the input buffer, put it into my program, I process it, and then output to system.out right now. That's my monitor. So how can I put it into a file? So to put it to a file, I need to have something called print writer. Let's call it out. So scanner versus print writer. So here let's do it. Let's do computer points.txt. Okay, so you will create a file called computer point.txt, and it's called out. Right. So I directly copy this line and then post it right here. This one is to the monitor. This one to the file, but to the file, you don't print it to system.out. I name it out because then I just need to delete the system dot. Then this one will print to the out. The out is a computer point.txt. So this one will print to a file. After you finish it, you do this. You need to do input close. You need to close your input stream. You also need to close your output stream. Otherwise, the file will be occupied. You will be in big trouble. Any questions so far?
No.
So must close, okay? If you don't close, you are in big trouble. So right here, this one is the system.out. You do print it, but let's go to my hard disk. And then there's computer points, computer point, where's computer point? Computer point, this one. Let me open with Notepad double plus, it's faster, okay. Visual Studio Code is slow. You see, it actually print out to the file. So this one tell you how to read the data from keyboard or hard disk to input buffer using scanner. Then you do processing it. Then you write to the output buffer. Output buffer can be system.out or your monitor or out or your print writer, that's your hard disk. So you can do whatever combination you want to have, hard disk to monitor, keyboard to monitor, keyboard to hard disk. Okay? Any questions so far?
No.
So this is very important, okay? Very, very important. We teach you this. Maybe for a while we don't touch this input again, but right here you need to know how to handle the input, okay? You need to know how to handle the input. So that's the part we
Wait.
do with question?
Can you show me the printing to a file code again, the print writer? Okay. No,
It's
but
just the opposite of the scanner.
so, oh, okay.
It's just the opposite of the scanner. You know what I'm saying?
Okay. Yeah. Thank you.
So here, if you don't call it out, you call it PW, print writer. It's okay. So this one you would need to do PW, the print line.
Okay.
Okay.
Thank
For
you.
me, I prefer input and output. Because what? Because you have the system that out, you print to the monitor is like this, and you delete this, you would print to the file.
Okay.
So I don't like to use a PW.
Okay.
Same thing for the input. Okay.
Okay. Thank you.
Okay. Any other question? Okay, next one is an expression. We talk about it. I think we'll go over it quickly. Okay, so this one expression is not hard. You just know about how to write a formula. Okay, this one, okay. A statement is the whole sentence. We talked about it already, where you will finish with the semicolon. And you take one action. So you have all kind of statement. You have assignment, you use assignment. You have increment. You have pre-now. You have object creation. So when you use object creation, there's always a new, okay? And there are some, if then else, we call it the control flow statements, okay? Call block, okay? Starting from parentheses to curly brace to curly brace. This is one pair of the curly brace. We call it a call block. So a call block forming a union of the function for main function. And this curly brace to this curly brace forming the block for the if. Okay. So inside the curly brace, you can put multiple statements in there. Okay, just like you are writing a paragraph. Okay, this is a call capsule encapsulation. This one are chapter, okay, this one actually not tested in AP, so we don't cover it. This one is Java 9 and above. Okay, we don't talk about it right now. Same thing for these, okay, Java 9 and above. Okay, next one we have a static program. So we do have, we use the class, a class can be a data class. So there's no static in there. Okay. You can have a program that has the static main program. So there are static and non-static. Okay, so static means it's a class function. Okay, so for the time being, we mostly use a static function. So you would have function 1 calling function 2, calling function 3. Okay, at this moment, we only teach you this. We call it static functions. Okay, we call it static functions. So right here, you have a physics class. You define the light speed Okay, 3 times 10 to the power 8. And then you have two functions, main function and the energy function. Energy function is E equals mc squared. Okay. So you use a mass to calculate the equivalent energy of mass. Okay. So you get started from your main program and run to here. It called an energy function to run this part. Finish it, return to here. Okay. So this one is a static function calling static function structure. Then sometimes you may have using the data class, we call it object-oriented programming. So object-oriented programming, your program will have a lot of different classes, data class, program class, different kind of classes. So those kind of classes and the array, we call it reference type. Okay, we'll talk about it later. But object-oriented programming will need that. So you do define a circle class, and then this one is the constructor, the builder of your circle. And then you have getter function and toString function to define your circle. Okay. So you can get radius, get area, get parameter, toString. So it's kind of preparing your data. Your data is called circle. And this circle may have radius, may have area, may have parameter. And there's a toString function to print out the data type. So circle itself is a class, is also a data type. You can use it to define data. So right here you say circle C1 equals new circle 3.0. You pass the radius layer to create a circle of radius 3.0, and then you can print it. So this is, we call it instance method. So this is different from your main static function. Static function is function calling function. This one is you use the object to call function. So this is object-oriented programming. Okay. And then this portion right here, we just want to touch base up to here. Okay. It's a little bit difficult, so not easy right now. We will do it later. Okay. But at this moment, remember that we are focused on this type of function calling function part first. But there are some other type of program. Okay. Okay. We are 9:03. Let's have a 5-minute break. Come back on 9:08. Okay. Have a break. We'll start and we will finish the program structure. We'll get started for operators. Okay. Give you a break. Any questions so far?
No.
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 The input and output are very important, okay? Because if you don't know how to handle the files, you basically you are DQ from the competition, okay? In the programming competition, you do need to handle the file by yourself. You need to read your own input file and output file by yourself. You must be an expert on it, okay? If you don't know how to handle it, you are basically out. So don't tell me that, don't say that I don't want you, okay? Some of the students think that they are smart, so they don't need to learn this, okay? They are in big trouble. Okay, anyway, this one we are going to talk about operators. So the operator, you had a plus sign, minus sign, multiply, division, and modular. I think everyone knows this, okay? Only thing that you need to know is for Java language, you have A plus B, or A divided by B. This one is an integer. This one is a double. Then the result will become double, the longer form. Okay, the longer form. If you have integer divided by integer, two integer, then the result will be integer. Okay. So if you have 3 divided by 5, you end up with 0 because the integer divided by integer. So you actually do 3 divided by 5, you got 0, 0, 3. This is your remainder, that's 3 divided by 5. This one is 3 10 modular by 5. This is quotient. This one is the remainder part. Any questions so far?
No.
But if you have a 3.0 divided by 5, then it's 3.0 divided by 5, you got 0.630. So you got 3.0 divided by 5, that's 0.6, no remainder, okay? Okay, this, you need to remember this. And then if you have a string plus 3, let's assume that you have a string plus 3. It is a string plus a integer, and you become a string. So usually if I want to convert a 3 of integer to a string, I just use double quote plus 3, that will become a string. That will become a string of 3. Is that okay?
Yeah.
But this doesn't happen in Python, okay? Python doesn't have this. Okay, so these are different operators. Floating point, you, okay, these are okay, I see, okay. Positive, negative sign, I think it's okay. Integer division, we talked about it already. Okay. Next one, increment and decrement. You have post-increment and pre-increment. This is post-increment, this is pre-increment. Okay, so pre-increment is you increase, then get the value. So let's look at this case. Your I is originally 1. Then increase I assigned to J, so I increased to 2. And 2 increased assigned to J. So you increase first and then assign the value to J. That's actually both are 2. And then if you have I plus plus, this means that I's value assigned to J first. Then I increase. Use I before you do some operation. That means your I1 assigned to J, then I increase to 2. So J equals 1, I equals 2. Is that okay?
Yeah.
So remember when you are variable before the plus is get a value first and then increase. This one is increase first, get a value later. Okay. Remember these two. So this one, I equals 10, you have new number equals 10 times I plus plus. I plus plus, your I assign a value of 10 multiplied with 10. So new number is 100, while I increase from 10 to 11. So new number is 100, I is 11. In this case, you increase first, so your I become 11 times 10, you got 110, new number. Your I is 11. Okay, so this one equivalent to you multiply first and then increase. This one is increase first, then multiply. Any question?
No.
So let's assume here we have I equals 5. So plus I increase to 6. 6 plus 6, you got 12 on K. So usually when we use a for loop, you use I plus plus. This is the same as I plus equals 1 or I equals I plus 1. These three are the same. I plus plus, I plus equals 1, I equals I plus 1. These three are the same. You write either way, it's the same. Any questions so far?
No.
Okay, this one, I don't work on it, okay? You get basically do translation on this one. So when you evaluate the expression, you do parentheses, exponent, multiply, and division, add and subtraction, okay? Just like what you learn in elementary school. Okay, that is part, I think, okay. Okay, we will see it when we have problem, okay? Then bitwise shift, we don't teach you. Bitwise operator, we don't teach you. This different one. Conditional statement, AP don't test, but we will teach you. Okay. So you need to remember this precedence. Okay, who go first? Casting is very high priority. Okay, casting is to convert some data from one type to the other. Augmented assignment. Okay, augmented assignment is okay. When you have an integer a equals 3.0, this is not okay. You will lose bits. Your double converted integer is not okay. But if you have double d equals 3, that's okay because your integer is shorter than double. That's actually fine. Okay, that's the first thing. Augmented assignment. Assignment is using equal sign. Okay. That means the right-hand side value, you evaluate and the value will be assigned to A. So when you have x equals s plus 1, let's assume x originally is 2. Then you are getting the value of 2 plus 1, you get 3 assigned to x. So the new x is 3. So this one, if you have A equals B equals 3 times 2. So that's B got assigned with 3, and then this B equals 3 will release a value of 3 times 2, so A becomes 6. So the equal sign has a side effect of returning the value of assignment. Any question?
No.
But usually we don't encourage you to write this way. It's very dangerous. Okay, this is okay, but legal, but not encouraged. So plus equal, usually like I plus equal A. Okay, actually usually I read it as increased by. So I increased by A. That means that I plus equals A. Minus equals decreased by. You deduct it by the number. Okay. I times equals A is I multiplied by. Okay, divided by modular by. Must remember this different augmented assignment. Okay. So I plus equals 10 is equal to A plus equals 10 is A increased by 10. Okay. So next one is casting. Casting is that you force the data from one data type to the other. Okay. So if you don't do casting, we call it explicit casting. I'm sorry, we call it implicit casting. You can convert integer to float or integer to double, that's fine. Okay, but double to integer, that's no. So going to the longer form is okay. Going to the shorter form is not okay. If you want to go from double to integer, you need to use casting. Convert it, okay? So by the I equals 100, this one is an integer. So you assign an integer to by, this one will have a grammatical error. This one integer assigned to long, this one okay. This one okay. So this is implicit casting, okay? So implicit casting is that you have two operands, you would be converted to the longer form, okay? Longer form of the two operands. And then if you want to force it to a certain type, you put it in front of you. So here you have 3.0, you force it to integer, you lose all the bit right here. Same thing here, 3.9, you lose over here. So these two get the same result of 3, okay? So this is a truncation of the fractional part. So this one x equals 5 divided by 2.0. This right-hand side is a double. Assigned to left-hand side integer, that's actually wrong. Okay, that's not allowed. So here I have a 23.4567. I want to take out this 2 digit. I want to round it to 2 digit after the decimal point. How can I do it? I kind of multiply it by 100, so this decimal point be moved to here. And then I take integer, so I take out integer, take out these two fractional part. Then I divide it by 100, so I'll get this number again. Any question? Any question?
No.
No.
If I want 3 digit, what should I do? Then here is not 100, you times 1,000. Times 1,000, you will move your decimal point to here. Take out the integer, take out the fractional part by quantization it. Then divide it by 1,000 again, it will give you the 3 digit rounding. Any question? But this rounding is truncation, okay? This rounding is truncation. If you want to do rounding, you have an integer, you have double x. You want to round it to a rounding, you use to x times point plus 0.5, take quantization. This will give you the mathematical rounding. Is that okay?
Yeah.
So let's assume x is 0.49 then. 0.49 plus 0.5, you got 0.99. Take quantization, it's truncated out, it becomes 0. If you have 0.51, you got 1.01, you actually truncated the 0.1, you actually become 1. So this one will give you the rounding in the mathematical sense. If you just do int, that is truncation of your fractional part. No matter how big it is, 0.000 is truncated out. 0.999999 is also truncated out. Okay? Any questions so far?
No.
And augmented expression. Here you have this, your integer is sum. Can you do sum plus equal 4.5? Yes. Yes, this one, yes. This one you don't lose bit, but you will become a forceman of this. You will do sum and then truncate it. This is augmented expression. Only augmented expression can do this. Any question?
No.
No? This one, I think you can write for yourself, okay? Be careful about integer overflow. If your byte is too small, sometimes integer, if you assign too large a number for it, it will be overflow. And then you may have 1.0 minus 0.1, 0.1, 0.1, 0.1. You are assuming that you get 0.5, but you don't. This we call it round-off error or quantization error, okay? That's because your floating point is not perfect. So never test 0.5 equals a 0.5 d. Okay, let's assume d is equals 0.5. Never test this. Never compare to floating point for equality. You may end up getting the wrong thing because of the rounding error. Any question?
No.
Okay, you have a num1 equals 1, num2 equals 2. So 1 plus 2, you get 3 divided by 2, you get 1. And then convert it to double is 1.0. It's unintentional division, unintended division. You finish the integer division before you convert it to a double. So how can you do? You actually, right here, this 2 must be changed to 2.0. Then that will be fine, okay?
Okay.
And then you want to input 2 variables, do not declare input 2 times. You just need 1. You just need to hook up your keyboard to the input once. You don't need to have multiple of them. Okay, there's a get change program, you can write it for yourself, okay? We don't write it. Now let's work on this display current time program, okay? Okay, I have so many seconds. I want to convert it to hours and seconds and minutes. So first, I'm going to convert it to hours. Is that okay? Is that okay? I'm sorry.
Yeah.
And the remaining seconds, okay? The remaining seconds shorter than an hour is this much. Then I divide by minutes. So far, okay? Okay, since you are going to use another second, so this one, let me multiply it a little bit. Let me pick up, okay? I pick it up, so the order value after it was modified, but it's okay. We still have it. Is that okay so far?
Yeah.
Divide, take remainder, divide, take remainder, okay? Now, let's create another one called time 2. So you get a system time from the computer. It is from January 1st, 1970. 12 a.m. early in the morning. Okay, that is that timestamp is 0. And then this one is in milliseconds. These are how many timestamp they are, okay? And then we actually would like to convert it to seconds. So we convert it to seconds, so we need to divide it by 1,000 because it's converting from milliseconds to seconds. But this one is a long integer, so you want it after the division, you want it to be converted to integer. So you need to casting it because we lose some bits. Okay, so you need to use an int to casting it. But this one is a Greenwich time, so you need to convert it by 7 hours. This is converted to Pacific time. Originally, it's Greenwich time, okay, where the London is, okay, where the London is. So you minus the 7 hours of the time from the time zone difference. But it's a Pacific time, so originally it was 8 hours, now we convert it minus with 7 hours. Okay, now this is okay. Then we do the same thing we are doing a moment ago. Let's just copy it, okay? Just copy it. We don't need to redefine second. We don't need to use a second order. These two we delete it, okay? So this portion we are going to rewrite it. So let's delete this one as well. We'll do system.out.print f. So we get a 3 numbers, hour, seconds, minutes, and second, and we print it in 3-digit format. It's wrong. Let me see. Hour, minutes, second. Oh, this hour is too much. This hour is too much. This hour, we actually need to seconds. Take modular by 3600 times 24. We need to actually take out rounding to a day to be within a day. Okay, this one rounding to within the day first because originally it has a year and the months and the too low. Here we missing a column. So it's 9, 38, 39. Okay. Any questions so far?
No.
So this one, you get the time from system clock divided by 1000 that become a seconds, and then adjust to us within the day because there are so many days you need to take out. Those extra seconds you need to take out. So minus equal this, and then you convert it to rounding to within the day. Okay. And then you actually convert it to hour, convert it to minute, convert it to second. You get this. Okay. Now let's actually write a times 3. I'm showing you the programming skills that we learned from this chapter, okay?
Okay.
So this one, you got an hour, but you will have a string. This is called conditional statement, AM, PM. Okay, AM, PM will be equals the hour greater than AM, PM will be assigned to it if the hour is greater equal to 12. Smaller than 12, AM will be assigned. Okay. So right here, we are going to put a percentage S and then put the AM, PM here. Then you can determine whether it's AM or PM. Okay. Then we may want to use a for loop. So there's a backslash F that clean the page. You clean the page and then print the data and then clean the page, print the data, print the page, and print the data. Once you print the data, you will thread the slip for 1000 milliseconds, that's 1 second, okay? This one also need to have throw exception. So every second is ticking now. Any question?
No.
So this is actually a clock. A clock that I get it from here, the system time, I use it to get a clock in Java. And it keep going, okay? So here you can see that it's still going, still going. It actually the program not stop yet. So if you want to terminate the program, you actually click this one, click, you will stop. Let's run one more time, okay? Keep running, keep running, keep running. The time keep going. You can also do tools and reset Java virtual machine. That will stop it. Then you stop, no longer running. Let's run one more time. Otherwise, you run it, you keep going. Every time refresh, percentage \F will clean the page. This one is called purge for a new page. Push a new page though over there is called home feed. Okay, so you clean the page, read a system time, convert it from millisecond to second, adjust to Pacific time, take remainder for the day, take remainder for the hour, take remainder for the minutes, take remainder for the second. Calculating the AM, PM, clean out the format, sleep for 1 second, and repeat it and many times. You got a clock, okay? So let's give you the example of using a simple operator to create a useful program, okay? And here we use augmented assignment, we use a division, we use a casting, we use printing formatted print. We use always while true loop and sleep for 1 second every time. Okay, these are the programming skills that we teach today, okay? Any question?
No.
Okay, after class, you can try it yourself, okay? No question, that's it for today. Good night and bye-bye.
Thank you.
Thank
Bye-bye.
you.
Thank you.